Let's say you're an operative who recently acquired a prototype Starfighter but struggled to figure out the controls and crashed it in different directions in a hangar before you were able to escape. You should use MSC Apex to do a quick loads analysis to make sure that the Starfighter is safe to take into hyperspace. If funding is tight due to the Empire auditing your benefactor's unusual financial transactions, as long as you're a student or a professor at a college or university, the Student Edition of MSC Apex can handle this job for free. Let's punch it. Many Bothans died to bring us these plans for this experimental Starfighter. Apex can import many geometry formats. Fortunately, the Empire uses Parasolid. Now, I already have some material properties set up for titanium and quadanium steel for the beams and the solar panels that make up this Starfighter. So now we need to assign corresponding element properties to the Starfighter. First, we can assign titanium to the hull, and the solar panels have element properties that tie them to quadanium steel. First, let's mesh this Starfighter. We will use 100mm elements for all surfaces. Now I'm going to select just the curves and mesh them with 100mm elements as well. While we're working on these curves, let's assign beam properties to them. That looks great. Now we'll assign 2D element properties to the surfaces. We'll make the hull titanium, and the solar panel element properties were already set to quadanium steel. Now we have a model of an experimental Starfighter. To connect all of these 1D and 2D elements, we will use mesh-dependent ties. I select all of the surfaces and all of the edges. Apex will then connect these based on which nodes are close to which nodes. To model the different impacts to which the Starfighter is subjected, I created several gravity loads, basically to direct the Starfighter, and constraints representing the obstacles that it would hit. This is enough for a simple analysis that gives us a general idea of what the loads are in the structure, but is not sufficient for stress analysis, especially in areas of contact, where we would need to use Sol 400. I have set up two scenarios. The normal mode scenario I'm really doing just to make sure that all of the parts are connected correctly with the edge ties. If I were using glue, I would want to do that kind of analysis also. For this static scenario, where we calculate loads in the Starfighter, I have several different load cases for the different impacts caused, as the Rebel operative was trying to figure out the controls on this prototype Starfighter. Our normal mode's results help us see that the Starcraft is connected correctly, and one could use them to figure out if the vibrations in the Starcraft would be dangerous to the pilot or whether they would make it prone to failure and fatigue. We also have lower order modes so that we can see all the ways that the Starfighter could fly around in space. Now let's look at the linear static results. They are animated just to help us visualize the deformation, and stresses are shown which we wouldn't ordinarily use for a loads model like this, but if you're in a pinch, it might help you make an engineering judgment. As the Starfighter crashes with the ceiling, we see high stresses where the lower wing is attached to that flange. As the Starfighter skids forward, its wings then tend to bow down. The most concerning load case is when it collides with the rear wall, which causes the wings to splay out, and for stresses to be elevated at the attachment between that horizontal mast and the flange. Based on these results, I would recommend that the operative get a mechanic friend to reinforce the connection between the wing and that mast before taking it up into hyperspace again. If you're a student or professor anywhere in the galaxy, and you want to learn or teach any kind of engineering simulation, from tripping an AT-AT to identifying a thermal exhaust port, you can use free Hexagon student editions. And if you're interested in finite element analysis, we have a set of tutorials that we just transported to the Hexagon archives using this R2 unit. If you want to do your own simulation of the Starfighter, the files for that are also on the Hexagon archives. Links are in the description. May the Force be with you.